Hello Gritten. We're going to have another video on the formation of covalent bond. Right, let's first record quickly what is done about bonding, what we spoke about bonding. Now, there are three different types of bonding: covalent, ionic, and metallic. The covalent bonding happens between nonmetals, and this is just a rule. Remember, as a general rule, the covalent bonding happen between nonmetals. The ionic bonding will be between metals and nonmetals, and the metallic bonding will be between nonmetals. Now, the number of electrons, or the electrons that are going to be involved in a chemical bonding, are called valence electron. Now, the valence electron are the number of electrons in the last energy level that are the number of electrons, or the electron that will be involved in the chemical bonding. Right, now then we learn that we use Lewis dot diagram to represent the bonding, and then in the Lewis dot diagram we have atoms and then dots which represent the valence electron. Okay, there are different examples we did previously. Now here, what is covalent bonding? Is when electrons are shared between atoms to form a molecule, and we have three different types of covalent bonding: the single, double, and the triple. Right, now let's see some examples. For example, let's draw the Lewis dot diagram for the following molecules. We have fluorine, we have hydrogen fluoride, we have water, methane, and carbon dioxide. So let's start with the first one. Okay, let's change the color. Better color, let's use the blue. Solution. Let's start with 1.1, fluorine. Okay, now fluorine is F2. So we have two fluorines that are bonded to form a molecule of fluorine. Now let's find out what is the valence electron for fluorine. We go to the periodic table. Fluorine is right here in group 17, and therefore it will have 7 valence electrons. So let's draw the Lewis dot diagram for each fluorine atom individually. We have fluorine, we have 7 valence electrons. So it has 1, 2, 3, 4, 5, 6, and 7. So you see, you have here lone pair, you have a lone pair, you have a lone pair, and then here on this corner you have now a single unpaired electron. That one is going to be shared. Now we have 2 of these fluorines. We have another fluorine which also has 7 valence electrons: 1, 2, 3, 4, 5, 6, and 7. Also with 3 lone pair and 1 single unpaired electron here that can be shared. So this fluorine will share this electron with the electron that is unpaired from the other fluorine. So what are we going to have? We have fluorine with the unpaired electron. This one is this one here, and the other fluorine with the other unpaired electron, this one here, and they are going to share. And then obvious, each fluorine will have the rest of the lone pair. This here is the molecule, the Lewis structure for the molecule of fluorine. This one here. Let's see example 2. Okay, example 1.2. Now in example 1.2, we're trying to do hydrogen fluoride. So we have H, F. Right, so hydrogen has 1 valence electron. Fluorine, as we said before, has 7 valence. So let's draw the Lewis dot diagram separated for hydrogen, which is hydrogen with 1 dot, and fluorine with 7. 1, 2, 3, 4, 5, 6, and 7. What can you see here? Okay, we see that hydrogen have only 1 electron that can share and fluorine has only one electron that can share, and therefore they are going to share those electrons. Okay, so we have here hydrogen with that electron, fluorine with that electron. They're going to share those two electrons, and then fluorine will still have the lone pair. Do not forget to draw the lone pair for the atom. Okay, and this here is the molecule of hydrogen fluoride. There we go. Let's go to example 1.3. Okay, let's go to example 1.3. Now, what is example 1.3? They say water, molecule of water. Water is H2O. We have two hydrogens and one oxygen. Hydrogen has one valence electron. Oxygen, let's look for oxygen now. Hydrogen has one valence. Oxygen, let's just go to the periodic table quickly to look for oxygen. We done it before, let's go back. Oxygen is here, it's in group 6, in group 16, therefore it has 6 valence electron. So oxygen has 6 valence. We draw the Lewis dot diagram. We do it for each hydrogen. One hydrogen, another hydrogen. Let's do it for oxygen with 6. 1, 2, 3, 4, 5, and 6. Note, oxygen have 1 and 2 lone pair, and oxygen has 2 unpaired electron that can share. They are the 2 unpaired electron that can be shared. So what is going to happen? The hydrogen will be shared with one of those unpaired electrons, and the other hydrogen will be shared with the other unpaired electron to form the molecule. Note, this lone pair, you keep it as they are in the same place where they are. You cannot move them from there. So you have oxygen with the lone pair as they are before. Here is one unpaired electron for oxygen, which is this one here. Then is one hydrogen there sharing those 2 electrons. Okay, and then here is the other unpaired electron for oxygen will be there, and then there will be the other hydrogen. This is the molecule of water. Let's redraw it a little bit more clear. There is the molecule of water, complete molecule of water. Let's look for another example. Example 1.4. We have methane. Now, methane will be 1.4. Methane is CH4. Right? We have 4 hydrogens and 1 carbon. Each hydrogen has 1 valence. Let's fix this. C valence electron. And carbon, we did before previously, but let's look in the periodic table to find out. Carbon is in group 4. Here's carbon. Let's clean so you can see it. There is carbon in group 14, and therefore it has 4 valence electron. Carbon has 4 valence electron. Okay, 4 valence. 4 valence. So let's draw the Lewis dot diagram for each hydrogen individual and for carbon. So they are the 4 hydrogens, and we have only 1 carbon with 1, 2, 3, and 4. Carbon doesn't have lone pair. All the electrons that it has, it can form bonds. Alright, so very, very simple this one. Each unpaired electron that carbon has will be shared with 1 hydrogen. Each one will be shared with 1 hydrogen. So the molecule will be 1 carbon in the center, sharing with 1 hydrogen here, 1 hydrogen here, the other hydrogen, and the other hydrogen. This is the molecule of methane. Let's go to the other example, example Question 1.5 is carbon dioxide. So carbon dioxide 1.5 CO2. So we have now carbon with 4 valence electron, and oxygen with, we said it was 6. Be careful with those numbers, 6 valence. Okay, now like methane, this one might be tricky because you have to identify what atom will be in the center. Right, so we have 2 oxygen. Let's draw 1 oxygen here with 1, 2, 3, 4, 5, and 6. The other oxygen here with 1, 2, 3, 4, 5, and 6. And we have only 1 carbon, 1, 2, 3, and 4. Now, note the following. If you place any of the oxygen in the center, the 2 bonds will be full. So you won't have a space for either 1 oxygen or 1 carbon. Therefore, oxygen cannot be in the center. So what we are going to do is 2 of these unpaired electrons of the carbon, 2 of the unpaired electrons of the carbon here will be shared with the 2 unpaired electrons of the oxygen, and the other 2 unpaired electrons of the carbon will be shared with the other 2 unpaired electrons of oxygen. So you will have carbon with the 2 unpaired electrons, I'm talking about those 2 that come in together, and these other 2 here will go on the other side. They moved. Now these 2 unpaired electrons of oxygen will move here. So we have now oxygen with the 2 unpaired electrons. Now the rest of the lone pair for oxygen must be drawn. There's 2, there's the other 2 lone pair, and obviously it's going to happen the same for this side. We're having the 2 lone pair of oxygen. This one here will move there. So you have oxygen, which is going to share those 4 electrons from carbon and oxygen, and the lone pair of the oxygen must be there. This here is the molecule of carbon dioxide. So here we saw some example of covalent bonding. We are done for now. Next time we'll have a video on ionic bonding. Thank you.